Welcome to this video on object-oriented programming in JavaScript. Object-oriented programming, the notion of wrapping our data and functionality in objects, is the heart of many modern programming languages. JavaScript gives us the ability to emulate many of those features as well. But to do it properly, we have to understand the distinct implementation style of JavaScript object-oriented programming. And we're going to discover that rests on understanding features like the prototype chain, like this _proto_ reference. Get those down, and the meaning behind the class keyword, the new keyword, all those favorite questions in seasoned developer interviews become much more accessible to us. So join us in this video as we go deep on how OOP works in JavaScript and become the proficient developers who can implement those features in our own professional code. Object-oriented programming. A hugely popular paradigm of writing our code at scale. Well, I'm no longer writing 100 lines, 500 lines, 1,000 lines of code, but instead tens of thousands of lines of code, and I have hundreds of developers working on my code base with me. I need a way of structuring it, of organizing it, that is a couple of things. One, easy for me to add features and functionality to it, maybe as another developer, without breaking what was already there. Two, when another developer picks up my code, they can reason about it and sort of see the layout and easily understand what's going on. That's both just because it follows a certain set of standards, but hopefully also because it's structured in a way that is meaningful given the needs that I'm going to have in my code base. We'll see what that means later on. And finally, that it's performant. Is my means of structuring my code going to be efficient? Is it going to allow me to do as much as I can without taking as many steps as I can, or without using up inefficiently a huge amount of memory space at this expense of performance? So object-oriented programming says, let's think about what we do when we write code. Essentially, we do two things. We store data in memory, and we apply functionality to data. In its heart, that's what we do when we write code. We store information, data, and we apply functionality to it. Now, don't get me wrong, it gets really complicated with lots of different functionality and lots of different data, but essentially we are writing functionality and data, and we're applying functionality to data. Think about a user who's got a score in a quiz game. I'm going to apply the functionality of increasing score to that user's score data, the value of their score. Given that, our object-oriented programming paradigm says, okay, if what we're really doing is just writing functionality to apply to data, and there's lots of functionality that applies to this bit of data, and there's lots of functionality that applies to this bit of data, could we somehow think of that challenge in terms of some structure? And what might that structure be? We're going to see in a second. Now, I will tell you this, whereas with our functional programming, our higher order functions, our closures, those we can very quickly see with a single function how valuable it is. It is very easy to see that map, copy, array, and manipulate, makes the life of writing out copy, array, and multiply by 2, copy, array, and divide by 2, much easier than writing all those functions out. So we instantly see the value of passing in a callback function, an additional set of instructions at the calling of the higher order function. OOP is not as easy to see its inherent value until we are dealing with complexity at scale. So we're going to have to play a little bit of a sort of imaginary game of building an application at scale. We're going to build a quiz game. It's going to have users, and here we only have 2 users, name Will, score 3, name Tim, score 6. I've got to imagine there's thousands of users all playing simultaneously with maybe many different properties associated with each user. A score, an avatar, a home page, a time zone, a login state or a log out state, all these sort of pieces, all attached to each individual user. And a ton of functionality that can be applied to each of these users. Here we've only got the ability to increase score, but we could have, log in, log out, change avatar, add avatar, delete profile, hundreds of different pieces of functionality that every single user, remember I said writing code is about writing functionality to apply to data. Every single user, all this data, we want all that functionality to be available. Because if all I'm doing when I write code is applying functionality to data, well then wouldn't it be great if all the functionality that I could ever want to apply to this user data is there right adjacent somehow. We'll see what that means, but somehow packaged up, bundled up, so that I know always that the relevant functionality will be there for my relevant data. Well, what would be the best way of somehow bundling up the relevant functionality that could ever be applied to the pertinent data at that moment? Or how could we bundle those things up? Lewis?
Possibly in an object.
Possibly in an object. And that is the heart of our object-oriented paradigm. It's saying the best way to structure what we're essentially doing in write code, which is applying functionality to data, the best way to structure that is to bundle the relevant functionality and associate it directly with the relevant data in objects. Note that we can have a whole bunch of different relevant functionality in reality, hundreds of these different functions. But in our essence, we are storing functions with their associated data on objects so that we can do this thing here. Oh man, if we can do this thing here, we are so happy. If I can run my relevant function, in this case, the ability to increment the score of my relevant data, the user1 score property, then I am so happy. This makes my code super easy for someone else to reason about. Where's the relevant functionality for this user object? Oh, don't worry, there it is, associated, and I can just run the function right to the right-hand side of the dot. That goal of having my functionality and data bundled together, everything we're going to see today is going to be about achieving that goal. Can I get my relevant functionality on my relevant data? If I can do that, everything else follows. That's going to be my fundamental goal the whole rest of this session. And we're going to start a very simple way of bundling the functionality and data together. Literally, we created one here by wrapping them using object literal. When you define an object by itself, it's called an object literal. We're going to discover there's more and more sophisticated ways, and that when we do it in certain early versions, there's trade-offs, there's costs of doing it that yes, it's very intuitive, very simple. Again, goal, object, containing data and functionality bundled as one, but there's going to be big downsides. But we're never going to lose sight that our fundamental goal in the entire session is, can we achieve calling the relevant functionality on the relevant data? For example, user1 dot increment. Is my functionality right there to the right-hand side of my data? This is known as encapsulation, binding together the data and functionality that manipulates that data, binding it together in a bundle. This is known as encapsulation. We're going to see a couple of ways of creating objects, just so we get familiar with a few different means of defining our objects. What's another way? Here I've declared a fully populated object literal. Skylar, what's another way I could have created this user1 object?
You could have set an empty object.
Empty object and?
Populate it.
With what type of notation?
Dot or bracket.
Dot notation, yeah, exactly. Let's see it. Dot notation. Create an empty object and then assign its properties using dot notation. Let's just do this one, talk through it line by line to make sure we're clear. Skylar?
So first we're going to declare a variable user2.
Yep.
Set that equal to an empty object.
Yep.
Okay, then we're going to access that empty object and store a key with name.
Yep.
That's assigned to the string Tim.
Yep.
Then we're going to access the same object, score, then set that equal to 6.
Right. I obviously do not know this very well. Yeah, 6, exactly, yep.
And then we're going to add a function on this key, which is called a method.
Yeah, exactly.
Increment, which increments user2.
Yeah, so we have an increment property known as a method because it's a function. Exactly, excellent. Now, are we calling increment here?
No.
No, we're just defining, we're just adding. Now we fill out all our properties, excellent. Now you said we can also fill it out with square bracket notation. I want to stress, bracket notation is never used except in one vital condition. What is that one vital condition, Lewis?
When you're trying to evaluate what goes in.
Oh, when you're trying to evaluate what's going to be the property. Yeah, exactly. Where I want to essentially leave, so user2, I could have, I don't know, property, and then this is an unknown right now. It's going to be evaluated when I hit this line. I'm going to look in memory for property and find that maybe property is name. So this is where I want to I want to leave it unknown yet for now. It's a variable. I want to have my property to be determined at the point I hit that line. So it's about handling variables that are going to then evaluate to an individual property name at no other time. Now, if your property name has a space or begins with a number or a special character, fine. You need to use, square brackets to do So I can't, yeah, here you go, something like that. But if you ever have a property name that is that, you've got bigger problems than using square bracket notation. So you're never going to use square bracket except for when you're always going to use it, which is with variables. Perfect. All right, top notation. Who can tell me another way of declaring an object? It's going to declare an empty object. It's using a built-in feature of JavaScript. Mijan, do you know another way of creating an empty object?
There's the Object.create.
There's the Object.create. Fantastic, Mijan, spot on. That's exactly it. Using Object.create. Well, this line here at the top here, user3, well, tell me, Philip, what's this line at the top here going to do?
It's going to create an empty object.
User3 is set as a variable on the left-hand side, and it's going to have assigned to it the return value. Return value, I'm sure where it's saying that. Object.create called is going to return an empty object. It's going to give us out of this an empty object. Now, you see the little null being passed in. We're going to see that you can pass anything. You can pass an object in with 1,000 properties. It's still always going to return us an empty object. By the end of this top line here, we have exactly the same thing as the top line here, user2 is an empty object. Well, with a slight under the hood difference we're going to see later on. User3 is an empty object. So keep talking me through it, Philip.
And then we access the user3 object, creating a property name.
Yep.
And assigning it the string EVA.
Yep.
Same thing, access the user3 object, giving it a score property and assigning it the number 9, and then accessing same object, giving it an increment property and giving it a function.
Yeah, so the method increment. What are we noticing here? We're handwriting out each of our objects here. Is this sustainable? No. We're doing something very repetitive. Z, what do we do when we have repetitive code? What do we usually do to avoid repeating ourselves?
Write function?
We write functions. Functions are what save us from writing things again and again. Functions are wrapping up instructions to then be used. Hopefully they're general enough, they can be used for each circumstance. They can be used again and again. Write them once, call them many times. Very powerful for that. Yes, we've got millions of users. We can't be having the developers hand writing out each of the user objects behind the scenes as soon as you start playing. I always imagine that. No, we can't do that. We instead wrap our creation of an object in a function, and then we can run that function and fill in the individual properties and then return out that object and store it in a variable. This is our first solution. If all we want to do, which we do, is be able to run our functionality, our relevant functionality on the relevant data. User 1 represents our relevant data with score property. Name will score 3, and then our relevant functionality increment that data. If all we want to do is that, then this is going to solve our problem. Solution 1 is going to be a beautiful solution. Super intuitive, but it is going to be fundamentally unusable. But we are going to see it so we can understand why it's fundamentally unusable. But it's doing its job. It's creating objects with data and functionality bundled together. So it's doing its fundamental job. Line 1, let's see it do its job. Skylar, what are we doing in line 1?
So we're creating a function userCreator
userCreator
with the parameters name and score.
Perfect, there it is, there's the function. Next line, Z.
We are declaring a variable called user1.
Yeah, user1, excellent. Now, do we know what's going to be stored in it yet?
Undefined.
Undefined, because it's going to be the return value, right, of calling what?
userCreator.
Yeah, user1 will be the return value of calling userCreator with what argument, Z?
Will and 3.
Perfect, will and 3. All right. I can't believe I still have my name on this. I wrote these slides years ago. All right, so we create everybody, this will feel good. Create a new
Execution context.
Perfect, all right. There it is, execution context, and in we go. And what's the first line of code say to do inside of this execution context? Or the first thing we do, we want to handle first, Lewis, inside the execution context.
We have a parameter name, and we're assigning it the variable will.
Yeah, the argument.
The argument will.
Yep.
And then we have the parameter score, and it's going to be the argument.
Great, now we enter the body of the function. What's the first thing you say to do?
We're going to create an object new user.
Yeah.
That's object literal.
Yeah, good. And assign it what properties?
Property name with the value of will.
Yeah, the name argument, right?
Yeah.
So, new user, that exists. It's an empty object. .name says add a property name and have assigned to it the name argument, the name argument that was stored in memory at the point which we fill the name argument in with will. So don't confuse the name here and the name here. The name on the left-hand side is a new property we're creating. The name on the right-hand side is referring to and retrieving from memory the argument with the value will. Okay, good. Keep me going. Philip? Oh, okay. Lewis?
We're creating a property score with the value of 3.
Yep.
And then we're creating a method called increment with a function definition.
Perfect. Final line of the function?
We're returning the new user object.
We are returning the new user object returned out
to global
into global memory, where it is stored in what global variable?
user1.
User1. There it is. Perfect. So now user1 gets filled in, no longer undefined, gets filled in with this object name, will, score, 3, and increment is a function. We've achieved the same thing we did when we hand wrote the object, but now we did it with just a single line, userCreator function being called and returning out an object. Perfect. Now, I'm not going to go through the entire next one, but we've now returned out to global, where the next line is what, Philip?
The next line is declaring a user2,
Right.
Setting it equal to calling userCreator, passing in 10 and 5.
Yeah, so it's going to be set to equal to the evaluated return, or the return value of userCreator called with the arguments Tim and 5. And that's going to return out, I'm not going to create the entire execution context, but it's going to return out what?
An object with a property name,
Yeah.
10, score, 3, and then an increment function, or
Yeah.
method.
A brand new, all of these were created inside of userCreator, just like this, but we're just not going to copy it out all over again. Everyone clear on that? We've gone inside next, we created an execution context. We didn't do all the stuff inside of it, but it's all been done and out returned this object into global memory under the label user2. Name Tim, score 5, and increment is a function. And so now we're going to test, can we do the thing that makes our lives as developers so effortless? Can we do it? Lewis, can I do user2.increment being invoked? Talk me through it. If I can do my key test of whether my code is doing its job. Talk me through this process.
So first you're going to look for user2, which is an object. And you're going to in global
memory, perfect.
And you're gonna look for the increment property.
And is it there?
It is there.
And it's a function, so I can successfully execute my function code. Fantastic. My job is done. My job is done. I have nothing more to do. I'm generating objects containing data and functionality attached. And I can run my function on my data. Am I happy? No. Z, why am I not happy?
Because you're making the same function for every single object.
He's spot on. He's exactly right. This is a beautiful benefits, not a beautiful solution. This is not a beautiful solution. It's a simple solution. It's not beautiful. This is a simple solution. But it's fundamentally unusable. We will never ever use this solution ever in practice. This solution returns out objects, each of which have a brand new increment function defined on them. Now, I'm not going to have one function attached to each user object. I'm going to have 100, 500. I want to be able to add login functionality, log out functionality, render user. I don't know. I want to be able to just do anything I want. And each of them is going to have a copy of that function. Maybe it's 100 lines in the function, 50 lines in the function, and I've got 100 functions, and I've got 10,000 users. I'm at 50 million lines, completely wasting the space. Now, don't get me wrong, Will 3, Tim 5, they're different. I need to take separate space for each of them. But these guys are not. These functions are exactly the same, and yet each time we create a new user, we make space in our computer's memory for all our data. Great. And functions, but our functions are just copies. Is there a better way? What would be a better way intuitively, Lewis, to somehow not have a copy of each function, the function on each object? What would be an intuitive, better way of doing it?
Perhaps creating an object that holds all your functions.
An object that holds all my functions, single copies of them, exactly. And then somehow, when I hit user2.increment, know to go looking, and it turns out JavaScript gives us a built-in feature to do exactly that. Anyone know what it's called? Don't shout out the title of the talk. Yeah, good. We'll talk about it in a second. All right. Solution 2 is going to be store that increment function, all the functions we want each of these objects to have access to, on the right-hand side of the dot as kind of methods, in just one object, and have the interpreter, that's the JavaScript engine, as it runs through our code. If it doesn't find the function increment on user 2, on user 1, doesn't find it on here, it's not here, doesn't find it, somehow it knows to go and look, let's call it function store, in some shared object where increment is happily sitting around. Somehow it knows to go looking there. How to make that link? JavaScript gives us a built-in feature of its own design that lets us make somehow a link to this shared function store, so that JavaScript can automatically go look up there without any sort of process from us. It's going to go looking up there automatically, without us having to specify go look there. Well, we will, but not at the moment that the line gets run. And how does it do it? It uses a feature of JavaScript known as the prototype chain. This bond is going to be called a prototypal bond. It's going to be a chain link up to here using this feature of JavaScript called the prototype chain, that's going to ensure when it does not find increment on user 2, it doesn't panic. It knows to go looking on function store, where what does it find but the increment function. So how's that going to work? How to make that link? The prototype chain, using the prototypal nature of JavaScript. Here it is at solution 2 in full. We're going to walk through it line by line, and we're going to discover a way to make some bond to this shared function store. All right. Okay. Here we go. Line 1Z. Sound like the word onesie. Line 1Z. Line 1Z.
We're declaring a function called userCreator.
That was very professional. Line 1Z, okay. All right. Okay. Good. Line 1Z. We're declaring a function userCreator, spot on. There it is, userCreator. Excellent, stored in global memory. Line 2, Megan.
We're declaring a variable called userFunctionStore.
Okay, nice. User function store.
And we're assigning an object.
Perfect. Into which we're storing?
Let's see, the property increment.
Which is?
It's a function that increments the score,
Yeah.
and another function called login.
Perfect. Excellent. There it is. User function store. All right. Next line, Lewis.
We're declaring a variable user1 in the global memory,
Yeah.
setting it to the return value of running userCreator with the argument will and ring.
Perfect. So it's undefined for now, and it's going to be the return value of running userCreator with the input of will, the arguments will, and 3. Create everybody and execution context. Perfect. Beautiful. It was mellifluous. Here we go. And in we go. And Philip, what's the first thing we do inside?
We take care of our parameters. We
Yeah.
set name equal to will
Yeah.
and score equal to 3.
Very good. And then the next line. Oh, now it gets interesting. What's this first line in the body of the function tell us to do? What's new user going to be after this very first line, Philip?
It's going to be an object.
Absolutely. And new user, here it is. New user is equal to Object.create. Pass in whatever. For some reason, we're passing in this user function store. Who knows why? We'll find out in a minute. What does this return out fundamentally, Philip?
An empty object.
An empty object. We're going to discover it has some hidden properties, but it is fundamentally an empty object that gets assigned to what, Philip?
New user.
New user. Excellent. There it is. Next line, Skylar.
So we're going to access that new user object
Yep.
and add a key name equal to the argument passed in name for score.
Very well put, Skylar. Yep.
And then do the same for score, so that equal to 3.
Okay. And then, final line of the function.
We're going to return
We're going to return the value of new user, the object, into what global variable?
into new.
We're calling into user1. We're calling userCreator. It returns out this new user object, or this object that was formerly known as a user, into the global variable user1. Perfect. Thank you, Skylar. Can we do our all hallowed thing of running on user1 the all important increment functionality? Can we do this? Talk me through it, Mejan. Left-hand side first, where do I look?
So on the user1 object itself.
Yeah, do I find an increment function?
Not directly.
No, I do not. Huh. 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 Anyone got any idea? Why would we do so much and then it'd fail? Turns out that when we declared that empty object, we made a special bond. Before we returned it out to user1, we made a special bond to user function store. When I created my empty object using this Object.create method and passed in user function store, it was saying make sure this object stored in new user gets somehow a special bond to this user function store object over here where increment's sitting happily. There's a special little bond over there. Meaning, when I return out this new user into user1, that special bond, and don't get this confused with other special bonds we have, like the other ones from Closure or other areas. This is a different one. It's got a special bond up to that user function store. Meaning, Mejan, talk me through what actually happens here.
So it's going to find, it's going to look in that special place.
Okay.
The underscore proto underscore.
Well, we're going to come to that in a second.
Okay.
And up it goes to this user function store where it finds
It does find the increment function.
increment, and it's ready to run it. And executes it, creates an execution context. Exactly, to run that code. Now, here's the question though. Here's the question. How is that special bond made? Well, I'm absolutely standing by that this is an empty object at the point at which Object.create is returning that empty object. I stand by that claim. But, it is an empty object with a special hidden property. Now it's not like our double square bracket scope property that we can't see. We can't dot console log. This is what we can see. If we were to console log our new user object and press a little down arrow, we see a bunch of hidden properties. One of them is double underscore proto double underscore. There it is, underscore proto underscore, which is, let's do it in pink, underscore proto underscore, which is a bond. It's a hidden property. We have to console log new user and then press a down arrow in the console to see the hidden properties. One of them is double underscore proto, and when we declare our empty object using the Object.create technique, which we know just creates empty object, but it gets this hidden property underscore proto underscore to whatever we passed in, which was user function store. A bond up to user function store, and that doesn't go away. So once we return that object out into user one, you return it out into user one, the output of userCreator, return out to user one, it still has that underscore proto underscore bond to user function store. There it is, that underscore proto underscore bond. So what happens is JavaScript has a built-in feature called the prototype chain, meaning when I run user1.increment and I go and look for user1 success and I don't find increment as a method, a function on it, I don't panic. JavaScript is automatically not going to give up when it looks for something on an object and doesn't find it, because it's going to go to that little underscore proto underscore and see what's there. User function store. Interesting. Let's go and see what's in there. And there's our increment function ready to go. And then we create an execution context with it. And this same function would also be available to, we're not going to run through it the whole way, but what would we, looking at our code there, what would we think user2 is going to have stored in it after calling userCreator with Tim and 5, Lewis?
It's going to have the proto.
Well, what's the overall thing? What is our overall?
It's an object that has the property name assigned to Tim and the property score assigned to 5.
Perfect. So we skipped over the running of the userCreator function and said when we call userCreator, its return value will be this object here, stored in user2. We didn't walk through the entire execution context, but it was happening, of course. What does this guy also have attached? Well, what's the hidden property? The underscore proto underscore hidden reference to user function store. There it is. So I could also run user2. User2.increment. Let's do it. Talk me through the process Z if I run user2.increment.
You're going to first look in memory for user2.
Perfect.
And you see that there is no increment function. Therefore,
Perfect.
you go to proto, which takes you to the user function store, and you find increment function there.
Perfect. And I take that code and I'm going to make an execution context in which to run it. All right. So when I do that, in I go. This increment function clearly needs to be usable on whatever object I run it on. And what that means is I need some placeholder inside of that function, increment, in order to refer to that object. Whether it's user2 when I run increment on user2 or user1 when I run increment on user1. I need to be able to refer to that object somehow from inside increment. I need a default label that's always going to refer to the object in which I'm running the function. Anyone tell me what that label is, Skylar?
The this keyword.
The this keyword, exactly. I'm going to have the this keyword by default. Here's our fundamental rule, always pointing to the relevant object to the left-hand side of the dot on which I'm calling this function. The object on the left-hand side, I'm calling increment on the right-hand side of the user2 object, and therefore inside of the execution context, this will be automatically bound to, set to, user2. And so now I can make sure I can refer to the exact object that I want to refer to, and my increment function is nicely general. It can be used on any object. Because I've only got one copy of it, so it needs to be usable on all objects that have been returned out of userCreator. So, what is our line of code inside increment, Skylar?
To access the score keyword of this value, and then increment it.
So this dot, exactly. So what is the this dot score plus plus going to evaluate to, Philip?
User2 dot score plus plus.
User2 dot score plus plus. Now, where is user2? If I look in my local memory, is that user2? No. So actually it's not going to find, it's going to skip one out, find user2, find the score property, increment it to 6. Beautiful. My increment function has become truly general, but I had to use this built-in this keyword. That's going to, here's our first rule for it. We're going to see another rule for it in a minute. Our first rule for it is it will always point to, always refer to the object to the left-hand side of the dot on which that function method is being called. That execution context is being called to the right-hand side of an object in which we refer to the method on the to the object on the left using the dot. This relationship here. This is going to be bound to the object on the left-hand side of the dot. That is our fundamental rule. We're going to see another way that this keyword works quite differently in a moment on one of our later solutions. But look, our first solution has been very successful. We've used the prototypal nature through this underscore proto underscore bond. Note, by the way, this does not say prototype. This user function store is technically known as the prototype of user2, the prototype of user1. But look at where the bond is stored. It's not stored in something called prototype. We're going to see a different property in solution 3 called prototype. Very unhelpful, in my view. But this bond is stored in something called underscore proto underscore. And we've used that feature to be able to achieve our fundamental goal. But look now. There's no problems with this guy. This is a beautiful solution. It's super efficient as well. Man, do we have any copies of increment stored on user 1 and user 2? None. Instead, we have one single copy of that function and other functions. We have as many as we want in here, and we can refer to them using this prototypal feature that means JavaScript knows to always go check the proto and see what's there. And by the way, look how easy it is for us to add functions up here, which will then be accessible to all the objects, even if we have them later on in our code, rather than having individual copies of every function on individual objects. Very, very inefficient. Okay, beautiful. Thumbs on this second approach. You lost me? I'm clear. I have clarifications. All right, everybody's thumbs up. This is a beautiful solution. This is a beautiful solution, in my opinion. No problems. It is efficient, maybe a little bit long-winded. Once you start thinking in terms of wrapping your data and the relevant functionality in objects, you do it for everything. Even if there's only ever going to be one instance of it, like a game board on which you play the game, there's only one game board maybe running at a time, you still end up producing it as an object returned from a function. You return it as an object with the relevant functionality for the game board and the data of the game board bundled up together. So once you start thinking in object-oriented style, you do it for everything. And so creating the object inside by hand, creating the object inside and then making the bond to the function store by hand and returning it out by hand. In other languages, we don't have to do that all by hand. In other languages, all that is handled for us automatically. We get the chance to do that automatically in JavaScript as well, using something, well, using a keyword that we're going to insert here. Oh, what could it be? What could it be? And this keyword is going to automate I say automate, it's going to, behind the scenes, insert so many of these pieces for us. What is that keyword, do we think, Z, which we insert to get all this superpower?
I think it's new.
It's a new keyword. I'm glad you got that right. I got nervous for a second. It's a new keyword. The new keyword is going to automatically. The new keyword, we call this, by the way, the object. The function that returns objects is called the constructor function. Constructs objects. Inserting the new keyword is going to automate multiple things. One, it's going to automate the creation of this new object. It's going to automate that for us. This is all going to be handled by the new keyword insertion. Everything in red is we don't have to write anymore. It's going to do all of this for us, everything in red. And it's going to return the new user object. Everything's going to be handled for us automatically with the new keyword. Okay, we're going to see who can spot immediately what this might do. It automates a lot of that manual work. It automates the creation of the object, and then it automates the returning of the object as well into user 1, just by inserting this new keyword. The new keyword just basically does a bunch of stuff inside this execution context for us. Who can see, though, how this might require a little bit of rethinking of how we write the code inside of this function? Philip?
I'm just curious on how we're going to create the bind, the underscore proto.
Okay. How are we going to make the bind, make a link to the user function store? Yeah, because we did that manually, right? By declaring our object using Object.create and passing in function store, we made a bond to that function store. Okay, so somehow we need to make a bond to a shared function store. Well, Java's going to make that bond for us. Well, that raises the question, do we get to set where that function store is? Do we get to call it something? Or does JavaScript instead choose a place for us to have these shared functions stored, and we've got to just use it? Well, it turns out it chooses a place for us and we just got to use it. Okay, we'll see that in a moment. What's another challenge that we, or at least a rethinking that's required in terms of the internals of this function now that we're no longer manually declaring new user is an object, add the property name to new user object? Mijun, what can you see?
So we're not going to have new user available to us anymore,
right,
as a label.
Our object is being made for us automatically. So we can't refer to it anymore the way we were before as new user.name. Instead, we're going to have to refer to it. Java's just going to give us a default label for it. Lewis, what's the default label it's going to fall back on? This. Very different this to the one we saw earlier inside of increment, where it's referring to the object at the calling of that method. This is a totally different use of the keyword this. The this here refers to the auto-created object inside of the userCreator function. Because we use a new keyword, it's going to automatically create an object and give it the label this. All right, we're going to walk through this all line by line, but it's going to require one other thing for us to understand before we move on. A funny old notion. Oh man, this is a funny thing. How JavaScript thinks about functions as both objects and functions. Oh man, this is funny. Okay, so we're going to come back to all of this in a second, but to understand, first thing I said is we do not get to set that our functions are the shared functions that all the objects that get returned out of running userCreator each time all get access to through the proto reference. We don't get to set it as user function store anymore, or function store we call it here. We don't get to set that anymore. That's done automatically for us. So JavaScript says, you don't get to set it, I'm going to put them in a default place, or I'm going to expect you to put those shared functions in a default place. Probably an object, right? So we can put a bunch of functions as properties on object. Where would that be? Where is that going to be? Well, it's going to take advantage of a funny old property of JavaScript, which we saw in callbacks and higher order functions, that all functions in JavaScript are actually really just objects that can have properties on them like any other object. Let's see that with our favorite function. Suppose I declared multiply by 2, and then I call it, let's just declare it over here. Declare multiply by 2 as a function, right? You know this stuff. Call it like this. It's going to return out, Mijun?
Well,
Yeah, hopefully 6. I mean, depending on how the
We
function works.
hope.
Yeah, let's hope. You know what I can now do? Or I can do it any time. I can also store on it, multiply by 2, a property, I don't know, score. And set that equal to, I don't know, 2. And then can I do, Medium, can I do this?
Sure.
Yeah? So if we return out 20, I've treated my function as an object, I've treated it as a function, and they are absolutely simultaneously acceptable. You can think of this, some people think of this as multiply by 2 is really always just an object, but with a special ability to be called. With essentially running its call property. It's really just an object, but a special ability to be called, that's the running of it as a function. I don't know if I always love that. What I prefer to think of is multiply by 2 has a function version, and it has an object version. And we can add properties to its object version. Score is 2, and that does not prevent it also having its function version. But you could think of the function version as being like a secret call property that's going to run the functionality. When I treat it as a function by putting parens on the end, I run the functionality. When I treat it as an object by putting a dot on the end of it, I get access to its properties. These are living simultaneously, they're not in conflict, they don't overwrite each other. Well, that means, oh damn, we do have a potentially useful object in which we can store our shared functions. And that is actually exactly what we're going to see happens, is that all functions by default are also objects, and all of them have by default a property on them known as prototype. It's a regular property on an object, which itself, wait for this, is another object in which we have nothing currently, but in which we could store all of our shared functions. We're going to see this play out, but just now know that our functions are both functionality that can be run and objects on which properties can be stored. And by the way, one of those properties by default is called prototype, and we are going to know that that's an object by default, and we're potentially going to store some shared functionality in that little guy there. All right. Let's do this line by line. Let's go through this with precision. But remember, we're just looking for a nice place. We're looking for a nice place in which to store all of these shared functions. And wouldn't it be great if we could use userCreator in its object format, and then somewhere in that object store those functions. We're going to walk through this very, very precisely line by line. And let's see our final solution here. All right. So, line 1, Mejan, talk me through what's happening in line 1.
We're first declaring a function called userCreator.
Absolutely. Let's be a little bit more complete on this time. So whenever we declare a function, what do we...
We store it in global memory.
Yeah, okay, excellent. But more than that, when I declare the function userCreator, I declare its function version. But what else do I declare, Mejan, by default?
Also got an object.
It's also an object. Let's make that object. It's also an object if we treat it as an object. Now, what do we say by default that object has on it as a property?
It's the prototype.
It's prototype, which is not something fancy, it's just like a regular property. Prototype. We could even overwrite it. Set it to 3. Not useful, but it's just a regular property, which is, there's the key. What's the value, Lewis, of prototype? What did we say the value of this prototype property was?
Increment?
Not quite. Philip?
It's an empty object.
It's an empty object. And I can have other properties. I can add all sorts of, we said like, what do we have, score before? I can have another property on userCreator. userCreator.score could be the score number 3, whatever. But I'd have to add that myself. But the default one that all functions have in their object format is a property called prototype that's an empty object. So far, by the way, This here has all happened by just declaring the function userCreator. It by default is also an object, which by default always has a property on it called prototype. Nothing special as the property string prototype, and it is by default a large, well not large, an empty object. By definition it can't be a large empty object, but it's an empty object ready to take whatever you want to put in there. Oh wow, I mean this looks like a damn useful similar place to our function store that we had earlier. And wouldn't it be nice if we were to run userCreator and the returned out objects would have access somehow to this function store? We used to manually create it to make the bond to it manually. Now we need a default place that we know JavaScript's going to be go looking. And it turns out that if we use the new keyword in front of userCreator, the objects that get automatically created inside and automatically returned out, their underscore proto underscore bond will be up to this guy. And let's walk through this with clarity. Oh, given that, look what we're doing. We're instantly putting some stuff in there. So Mejan, what are we putting in? Talk me through, this is a little bit fancy. Talk me through word by word what's happening here. We've declared userCreator, we've not gone inside of it, it's automatically got a bunch of stuff on its object version, and now we start making use of those. Talk me through word by word here, Mejan.
So we're looking at the userCreator function.
Yeah, hold on, let me just get my green tracking pen. Okay.
Specifically, we're looking at the prototype property of that function.
Which is?
It's an empty object.
Perfect. So far, by the way, we've been referring, not creating. What do we do when we hit this word here? So we've been referring to userCreator, where we refer to the prototype property, and then what are we referring to login here?
I'm sorry.
Are we referring to login, or are we creating login at this point?
Oh, we are actually creating it.
Exactly, and that's the funny thing about this, is when you see that userCreator.prototype.login, you're like, which bit of this was already here and which bit wasn't? UserCreator was definitely there. Prototype was definitely there. Login was not there. So what do? We create it and assign to it
a function that
perfect.
Just console logs login. I think we might have left behind one method as well. The increment.
Oh, whoops.
That's why I was giving you a puzzle.
Oh, damn it. Increment has been. Why did I think it said login? All right, there it is. Increment. So okay, I see. Yeah. Oh, yeah, it's good. UserCreator is referred to. We then look for the prototype property on it. There it is, which is a big old empty object into which we now store the
functionality.
Yeah.
Okay, we're assigning the property increment
Good.
to it and assigning it to the function.
That function, the method. There it is. Excellent. Next line, Mejan.
Now we're going to the userCreator function. We're going to its prototype.
So we're going to the userCreator function in its object
property,
version.
right, in its
Prototype,
object version. And then we are creating an additional property called login, and we're assigning the function as its value.
Fantastic, as a method. Fantastic. We have not run any function yet, but we've got a whole bunch of stuff now here stored, and we've kind of, in the end, achieved what we did before. We had a userCreator function, and then we had a function store, if you remember, with an object full of functions separately. But now, we're putting it right on the function itself. It's kind of still a weird place to put it, I realize, because, oh man, it feels like they're going to be attached to objects that get returned out, but it's just a storage place. It's just a storage place that JavaScript's going to go to by default. All right, so next line, now, Lewis.
We're creating a variable user1,
Okay.
memory, and then we're calling new userCreator.
Okay, so for now it's undefined. And so now we're going to do our key piece. User1 is going to be the return value of running what function?
userCreator with the argument Eva and
perfect. Yeah, and note, we are running a function here. This is not some special function. No. It is just a function. But we're going to mutate its behavior inside using what powerful keyword?
The keyword new.
The new keyword, exactly, which is going to insert a bunch of stuff into this function. But for now, we're going to create everybody with execute a function in new.
Execution context.
Execution context, fantastic. There it is. A new execution context with a local variable environment or a local memory, whichever you want to call it. Okay. First piece we're going to do is handle our arguments. Lewis, handle the arguments for me.
So our first parameter name is going to be the argument Eva.
Great.
Our second parameter score is the argument 9.
Perfect. Okay, here we go. Now the new keyword shoots itself in and starts doing a bunch of things. What's the first thing it does, Philip?
Creates a empty object.
Empty object. Okay.
And we give it the name this.
That's spot on. It's going to create that empty object for us by default, and in order that we can refer to that empty object, in order to add properties to it, we've got to give it a label, and that label set for us by default is the keyword this. We can think of this sort of a bit like we had before. This is equal to Object.create, which we know returns out an empty object. But it doesn't just do that. What else does it do for that object? What else does that object get?
Gets a bind.
It gets, be careful saying binds. We often use that to refer to what this keyword refers to. So it's getting a bond, a prototypal bond through the proto reference. It's getting a bond. So I'm using the same word. It's getting a bond to the shared function store. And where is it defaulting to that shared function store being found?
The prototype of userCreator.
Yeah, let's say the prototype property is the prototype object, which is a property of userCreator in its object format. Because sometimes it's tempting to think, oh, it's in the prototype, that's some special mystical place. Nah, it's just an object that happens to have a posh name prototype. Who knows why? Nobody knows. All right, so it's an empty object, but has a hidden underscore proto underscore, which is a reference to where, Meejun?
It's the userCreator.prototype.
Fantastic, which is this function store object. Perfect. Okay, so far all of this has been done for us by JavaScript without us having to do anything because of what keyword for that?
New. The new keyword.
The new keyword, great. Now finally we come back in, and what do we do, Philip?
We give this object a new property called name, and we assign it to the argument name, which is Eva.
Yep.
We do the same thing, we give it a property score, and assign it the value of score, which is 9.
And now our work is done again. So what is the final thing that new keyword inserts for us, Meejun?
It's just returning this.
It's returning the value of this, which is the object. It looks a lot like the object we created by hand before. Returning this. Into what global variable?
User1.
User1, fantastic. User1 is now that returned out object with name is Eva, score is 9, and the hidden underscore proto underscore reference to userCreator.prototype, which is just the location, just the place we're going to go looking for our shared functions. So now we ask ourselves, can we do our all-important challenge Z of user1.increment? Is our functionality there available to us on user1? Talk me through it word by word, Z. Where do I look for user1?
We look in the memory for user1.
Do I find it?
We do not find the function increment.
Oh, I don't find the function increment on user1.
Therefore, we go to proto, which is linked to the user-creator, and then we look for the prototype property, and then we look for the...
Which is an object.
And then we look for the function increment.
Do we find it?
Yes.
We do, and we grab its code, and we start running an execution context of that code. We've achieved everything we want to do. We have a beautiful available function to us on our relevant data. We can do this on user 2, user 3, user 1000. But man, look how much our new keyword handled for us. Look how tight and tidy our code is. No more making of that object by hand. Oh, one other thing to add. So what is basically passed into Object.create here by new? Meejun?
userCreator.prototype.
userCreator.prototype, that object, exactly. That object of shared functions, we want each of these objects that gets returned from calling userCreator to have access to. Now, note one thing. If I ran userCreator without the new keyword, do I automatically create a this empty object? No, right? Without the new keyword, the this.name and this.score, what's the this going to refer to? JavaScript never leaves anything unevaluated, unevaluatable. It's going to point somewhere. Skylar?
The global memory.
Not global memory quite, Regent?
To the global object.
This global object known as the window in the browser, which is a collection of features and functions of JavaScript. But it is definitely not what we want to have the name and score property set on. So this is to reiterate, every JavaScript's runtime, that means the space in which it's running, has a built-in object full of a bunch of properties of JavaScript called the window, and in Node it's called the global object. When I call a function, just a regular function like userCreator with no new keyword, and that function is not being called as a method on an object, userCreator is not being called as a method on an object, it still has a value for this inside the local memory. But that this is bound, this is what we do use the word bound, is bound to that random global object, which is of no use at all. And this has been a very big frustration for people when using JavaScript. And in a way, I do think it's a flawed feature that I need to second guess that the userCreator function requires a new keyword. Often inside of a userCreator function or a quiz question creator function or whatever, I'll actually have a whole bunch of new functions defined, and my first reference to this will be way down. And I'll think I can run the function just good to go, see what happens. And all sorts of crazy stuff will happen because the this is being bound to global object. So, regret. Anyway, so what do we do to ensure we know that that userCreator function must be run with the new keyword in front of it, Philip?
We capitalize the first letter of the function.
This is a flawed design feature that we have to personally come in and capitalize so that I know to run this function that it will not work remotely as I've designed it to work because if I don't have the new keyword, because look how much I was relying on the new keyword to make it work. That's a flawed design feature. So we step in as JavaScript developers and would run userCreator, we'd define it with a capital U at the front. And therefore we all as developers have developed a sort of standard that we know that's going to require the new keyword in front of it. Okay, folks, thumbs on this, our third solution. We have one more solution that's going to prettify it even more since ES6 came along. But in our third solution, thumbs on this model. You lost me, I'm clear, I have clarifications. Everyone's thumbs out? All right, we are all clear. What do we think of this model? Benefits, faster to write. I had to write less stuff. Look how much JavaScript came in and helped me. Still typical practice in professional code. This is still increasingly not the standard. We're going to see solution 4 is increasingly the best practice, but you'll still see plenty of code written in this style. You will never see solution 2 written. And yet, knowing that solution 2 is what gives us solution 3 is why you will have the depth of understanding to, in interviews, answer that key question. What is the new keyword doing under the hood? And even, can you build the new keyword from scratch for me? Because you have every damn piece that goes into the new keyword, because you build it from scratch yourself in solution 2 with Object.create. All right, so downside of it, 99% of developers have no idea how it works and therefore fail interviews. All right, our final solution 4 takes all this and says, still, this is not similar enough to traditional object-oriented languages. We still need some way. In the traditional object-oriented languages, we are right now, what do? We did userCreator.prototype.increment is a function, userCreator.prototype.login is a function. We hand stored them. We stored them by hand. We stored them in this prototype object by hand. In other languages, functions that are shared between all returned objects are not stored by hand separately. Let's just make sure we have our user2. What would our user2? Well, let's do our standard one, which is name, Tim, score, 5, and that would also have a proto reference to userCreator.prototype. This guy here. Okay. We are here writing our shared methods, the methods that are available on all these objects, we're writing them in separately. What does that mean? Let's see. That means we stored them associated with userCreator ready to be available on user 1. We stored them manually. In other languages, you don't do that. We store them separately from our constructor. We define our function that constructs and returns object, and then we separately store the functions on it in the prototype object. Super explicit still, at least we're still saying exactly where they're being stored. Well, that's still, unfortunately, too explicit. We want to hide even that. We want to make us think even more that under the hood this works like a traditional, known as classical, object-oriented language, even though it fundamentally does not. And so, other languages let us do this all in one place. ES2015, ES6 lets us do that also in what's called the class syntactic sugar. The class syntactic sugar takes the function definition piece of userCreator and calls it constructor. It's exactly the same functionality. You see this.name equals name, calls it constructor as a sort of subtitle. And then it takes the functions that we manually stored, userCreator.prototype.increment, and it allows us to just list them below, and then we wrap the whole thing in something called a class. And you can call this userCreator, but class userCreator. And that's all that's changed. Let's go through this to make sure we're really, really clear on this, because it can be, I don't want to hide it is really this simple. It really has nothing's changed. Class user, well, we can think of this combination of these two parts. Class is technically a different data structure, data type in JavaScript, but for our benefit right now, we can think of this as being our class. So we define the userCreator class comprising its function version, the bit that when we call userCreator, is going, we now call it user. Call user is going to run the function version of it. What subtitle does it give, Philip? The bit which we used to call the function version of userCreator? Constructor. That's a subtitle, but it is absolutely, when I call the userCreator function, we're going to call it the user here, but the userCreator function is going to grab that constructor subtitled bit and run that. Well, that's exactly the same as what I had in version 3. Called it userCreator, and then we ran userCreator, we were running the function version of it. But we added to the object version of it these shared functions, a shared function store. Well, here we don't even have to manually do that, but no, they're going in exactly the same place. All functions that I list below this constructor function are all going to be added to the userCreator.prototype shared function store. They're going to be when I added increment, when I wrote increment there, JavaScript's going to pass through this C increment. It literally takes each of these pieces as it defines it, not like later on. As it defines it, it goes, looks at increment, grab increment and store it in userCreator.prototype, and there it is. And then it sees login, and it's going to grab it and store it in userCreator.prototype.login. And then when I run userCreator, or you call it here user, when we run it with new, what are we doing? We're grabbing the constructor subtitled bit, we grab it, and we're going to run it just as before. Nothing has changed. This is why it's called essentially syntactic sugar. That's a word meaning prettifying, but nothing under the hood has changed. Now, don't be wrong, class gives you a bunch of new features under the hood, but for our purposes here, nothing has changed. We now have an even cleaner version and even less representative of what is happening under the hood. Ah well, good. So there's the function user constructor piece replaced here. Here's the storing of increment and login. We just list them out. We don't even write the word function. We just literally list them out, no commas, just throw them in. All right. So, benefits emerging absolutely as our new standard. Feels more like the style of our language. This is almost identical to Python. And I don't love this as not owning the fact that JavaScript is a very powerfully prototypal language. All this stuff under the hood is using the proto-references. That's not how OOP is implemented in traditionally OOP languages, believe me. But I guess it makes it accessible, makes it feel similar. The downside is 99% of developers have no idea how this works, making it inherently challenging to debug it. to explain it, to talk it through to other developers. But you will not be one of those folk. Congratulations, guys. That is all of OOP in JavaScript. We're there. All right. Thank you.